Now because it's kind of funny. I had to make a decision. I either had to edit this down to 90 minutes and take out a lot of slides because this is an unusually short presentation. Was anybody at my presentation last year? Yeah? Okay. You know how many slides were in my presentation last year? Guess.
880 something.
854. Good. Right there. Give him one. That man deserves one. All right. This is an IOU. I ordered a couple of dozen books to come today, and unlike you, they didn't make it. So this is an IOU, and it's good for a book at some future date or a drink at the bar tonight. Your choice. Maybe both. All right, so anyway, just to let you know that was a bug. I have had exactly 24 pages in that pad, but I have one more pad. So if need be, I can mint some more, but I can't do it in real time. Now, what else do I want to say? How many people were at Sean's talk? Oh, crap. All right, I want you guys to pay careful attention. Sean and I had a long drink at the bar when I first got here, and we talked about a lot of stuff. We don't agree on everything, but we don't disagree on that much. The interesting twist, and what makes this talk important, is the details of the semantics, hence the name of the talk. So I want everybody to try to pay attention to the differences between Sean and me and the similarities between Sean and me. There are way more similarities than differences, and I use different terms. Some of the terms that Sean uses are, I'm not sure, well, they come from a different, vintage. Some of my terms are from Grady Booch. And so, could you remind me again the name of that thing I talked about on the way over here? The essential functions?
Computational basis function.
The basis functions. Like he'll use basis function, and I'll use primitive function. They're the same thing. Just so you know. I've never met him before. Heard a lot about him. So anyway, that's the pre-talk. So my goal here, I'm going to present more information than you could possibly assimilate in 10 hours. But I want to do it in under 90 minutes so we have time for questions. Now, I barely broke 600 slides. In fact, I don't even think I made it to 600 slides. So this may end early, just so you know. And I'm going to get started. Now, you aren't going to be able to read any of this stuff because it's for the camera. We're just going to have fun today. That's all we're going to do is have fun. But I'm going to make sure every slide gets up there so that if you want to go back and look at the details, you can. So here's the abstract. And you can freeze this on the video, but we're not going to worry about this. The key thing is we're going to talk about what the meaning of value is. Okay? So here's our outline. The color isn't all that good there. We're going to start with this introduction. Now, I put this introduction in every single talk that I have, so there's no reason for me to talk about it. I'm just going to show it. You know, the thing about physical design, it's something that I put in that book from 1996. That's probably the most important contribution I have to the community. I think value semantics might be second. That's my opinion. Physical design is definitely number one. So this is a component. We have an implementation, a header, and a test driver. It's not really relevant to the talk, but I want everybody to know that this is a component. Okay, it's a fundamental unit of design. And yes, we have to take components and rationalize them with physical stuff. So we got logical content inside these physical components. And yes, logical relationships do imply physical dependencies. This is like the commercial before the talk, okay? And we need to understand different categories of types because if we don't have a basic shared knowledge of what's going on, it's going to make the ability to just communicate with other people that much harder. Whereas if we use the discipline to say, look, I'm going to write this type. It is a simply constrained value semantic attribute type, and it has these attributes. We're done. We can almost generate that. So it's very, very helpful to have this shared context. So sort of the other part of this is while we're talking about value types, we're also talking about what isn't a value type. Now here's an important point. When I was coming to this hotel, I had a discussion in the car, and I was told, you know, really like your stuff, but you should read more. You should understand what what value semantics really means, because it's well understood. Then I got to the bar and I was told, John, you know, this is way too esoteric. I thought you were a practical guy. So I like two extremes, you know, back to back, and I just can't. I'm like, okay, I guess I'm in the sweet spot because I'm in the middle. So here's the big picture. This is a sort of a taxonomy of types, and we'll just poke at it as we go along. These are common categories, and again, this is just for the camera. We're going to talk about value types. Okay, so that's introduction, done. Only 3 more things to talk about. Sure. All right. So here are the things we want to talk about. Do these look like reasonable things to talk about? I'm just curious. Is this reasonable? Because if you're at the wrong talk, now's a good time to leave, because this is what we're going to talk about. I got to bed very early this morning. I must tell you, normally I'm up all night working on slides, but I actually slept 6 hours. I'm not a morning person. I do need some water. Is there water here? Let me just 1 second. Leaving. Coming back. All right. So this is what we're going to talk about. Getting started. This is a true story, and this actually was part of my talk in 2008 at the ACCU. So you've probably seen some of these slides before, at least some of you have. But the point is, more than half the slides are new, and that's where the beef is. So I'm going to go through the old slides very quickly. And if anybody thinks it's too quick, just stop me. So we're going to go, so let's begin with understanding some types, and then we're going to talk about the details. Is the projector okay? We're missing a little bit on the bottom. I do have some stuff. Is there any way to adjust that so that it's a little bit higher? Just a little bit. All right. So this is a true story. So you may know that back a long time ago, I was all about allocators and getting them into the standard, because there's a reason for doing that. And I was sitting in this meeting in Hawaii. It had my proposal had just been deferred till the next meeting, and I wasn't happy. I'll tell you right now. And I'm listening to this stuff, and there's a bunch of people in a room with no windows in Hawaii. We're right outside. There's sunshine. There's the ocean. You know, there are pina coladas and mai tais and and I'm sitting in here in a room with a bunch of very smart men with no windows, all with laptops, and I'm not happy. So anyway, and they're talking about this thing called match result. Like, what are you guys talking about? I don't know what this is. Turns out match result has something to do with thing called regular expressions. What's going on with that? And they say, what do you mean this? What do we mean by the same? Because they said it was, these two match results were the same. And they didn't particularly know what it even meant. So they had some things in common, but whatever. Now, I was new to the standards committee. And when you have that many smart people talking past each other because they don't know what they even mean or even how to express it, it's kind of interesting. So it was clear. Now I'm putting this up here quickly because this made me even more irritated. And it was actually a great thing. When I get irritated, I take action. Like Nico does, I know it. All right, the discussion continued. Whatever the copy constructor preserves. Is that true? We'll find out. As long as they're equal. Oh, that solved it. Now we've got it. They're equivalent. Okay, why didn't you just say so? You know what I mean. They said that. All right, anyway, they decided to leave it to the editor because it's not important. Seriously. So anyway, I'm putting these slides up quickly. I want to give you a little bit of background on what's going on. What do we mean by value? Get ready. Somebody, not yet. You get only one piece of paper. I'll buy you a drink anyway. Somebody tell me what we mean by value. First person that says something gets a paper. Raise your hand. Go, okay.
Set of attributes describing an object.
Give him a paper. Set of attributes describing an object. There you go. See, it works well. All you have to do is talk, because we have to get through this quickly. What does a copy constructor do? First person to raise their hand?
Copies the value.
There you go. Give him a paper. All right. Okay, now, no papers. Let's just talk for a second. After copy construction, the resulting object is... Who said a copy? You already have a paper, don't you? Okay. Okay, substitutable for the original one with respect to some criteria. What criteria? Is it the same object? So in other words, what do we mean by that? Does it have the same address? Okay, it doesn't have the same address. Is it Java-like in that if you change one, is it going to affect another one? No. Okay, good. Okay. Has the same state. Who thinks that if it has the same state, it has the same value? No? Okay. No one. Good. So we have a string class here, and what would happen if two string classes had the same state? Footprints were identical. Problem, right? Okay. So, no. Same behavior. Who thinks that if two objects have the same behavior, they have the same value? Now, surely someone's going to raise their hand, get a piece of paper. There you go. Give that man a piece of paper. You're not right, but you got a piece of paper. If we apply the same sequence of operations to both objects, the observable behavior will be the same. So here I made up this crazy function f takes a bool, and to one thing I created a vector, and I reserved some space, and then I created another vector as a copy constructed from the first. And is the capacity copied or not? We see no, it's not. Okay, that's not true. It's not specified whether it's copied or not, right? Right. Give him a paper anyway.
He probably has your book. Everybody wants a drink.
Yeah, I'm going to buy him a drink. I had to talk to him.
No, I don't have the book. Oh.
You don't?
No.
Shit. You guys are late. We're already almost done. All right, anyway, the point here is that even if it's not a value type, two objects have different addresses, so I can always construct a program that will behave differently depending on which instance of the type. And this is just an example, and I think you can read through it in the lectures. I'm not trying to do... Okay, so this is not the case. Just because they have the same behavior doesn't mean they have the same value, or if they don't have the same behavior, doesn't mean that they do... you know what I'm saying. Right, okay, it's early. I'm not a morning person. So what's the same after copy construction? And now here's the thing, it better be easy to understand. Because if it's not easy to understand, who's going to follow this, right? So we need guidelines, right? So the two objects should have the same value. Okay, talk's almost over. Everybody understands what value is, right? No? Okay, it's not. What do we mean by value? Okay, we don't mean this. So mathematical types. Now this is where I get into loggerheads with other people, because some people get a little bit too mathematical and then some people get a little bit not too mathematical. I'm really trying to, split the difference and be practical, but, thinking ahead. So let's talk about this, because this is actually really important. You look at something like an integer. There are many ways to represent the integer 5, but everybody in this room knows that there is exactly one value, 5, 1, not many, 1. I can represent it many ways with many different variables. I can write it on a piece of paper. I can program it in Java or C++, but there's just one. And all of those representations refer to it. That's important. Now, this is mind-bending, but there's only one value, 5. Now, there's also a notion, and I realize that this is obvious to me because I've been thinking about it for 20 years. It's obvious. No, it's not. Operations, mathematical operations, they exist somewhere else, like in another solar system, another galaxy. They exist for all time, and we discover them. We don't create them. We discover them. Math is discovered. That's my opinion. We discover these things. And so there are operations that exist. If I have the value 3 and the value 2, and I apply the mathematical operation plus, the result is 5, however we get there. And there's no baggage in 3 and 2. There's no allocator, there's no capacity. It's just 3 and 2, that's it. There's nothing left over. And that is critical to understanding what we need to do with the meaning of objects. All right, we're going to talk about this more in a moment. C++ type. Okay, so it may be an approximation to a value, and it may not. Some people may tell you that more objects than you think should be values, and some people will tell you that fewer objects should be values, or should represent values. I don't want to say be values, because objects are not values. Objects are variables that hold values. Sorry, I misspoke. I want to be very careful about this. So an int is an example of a representation of a type that approximates a value type or a mathematical type, okay? And these values are globally unique, but remember that a C++ object is just another representation for this type that operates on its own set of values, okay? So this is totally rudimentary. I'm going to go through it quickly, but can you tell me what's wrong with this class? Somebody can tell me. I know it's a complex one, but something's wrong with it. What's wrong with it? Raise your hand.
Well, the interface of the methods doesn't match the data type.
How many people agree that these things have to match these things? Anybody? Do you agree? You're thinking about it. Okay. What's wrong with this is right here.
No const.
Right. Why don't I use const? There's a very good reason. You thinking hard? There's no room. That's the only reason. Okay, so I have two different classes. I have this class date and that class date. They both have the same visible attributes, but they represent the thing, whatever it is, the date. What do they represent? What is it called? They represent the what? Value. You do have one already. Sorry, can't have two. Now, interesting concept. It's not really the most important part of this talk, but if I have these two dates in different computers, because obviously they have the same name, or even in different namespaces, if these two things come back with the same year, the same month, and the same day, do they represent the same value?
Yes.
Who said yes? Give this man. That was quick. That's good stuff. All right, they do. I claim they do. Well, why? Because the mathematical type that they approximate is the same. Right? If it were different, it wouldn't make any sense to even have that discussion. Okay.
Not necessarily the same, but okay.
Not necessarily, but here, but no, but
Except where you program these two classes.
hold on. Now, this is important. This is why this could go on till the evening.
Yeah.
This is important, what he just said. The only thing that matters is were these two classes programmed to approximate the same mathematical model? They either were or they weren't. If they were programmed badly, that's off the table. If they were, then the operations are the same. The span of values they can represent might be different, but when they overlap, because these don't represent the same subset of values, they represent different ones, right? And the one on the right with the serial represents a larger span than this one because there's waste here. Okay? All right. These are called salient attributes. Now, the documented set of observable named attributes of a type T that must respectively have referred to the same value in order for two instances of T to have referred to the same value. This is naive. Wait till you get to the end of this talk. Your head will blow up. We're just at baby stuff right now. This is a test. Notice there's different representations. Do these two objects represent the same value? Assuming that they were implemented in terms of the same mathematical model.
Yes.
Yes, okay, good. So that's the value. What would be, now this is, we have a few of these in here. I put these in last night or this morning to see if you guys are paying attention. The first person to answer correctly gets a paper. Who wants to try? Go ahead.
I tried tuple of characters.
Okay, you already have a paper, and that's not what I would, tuple of characters? I don't think that's true.
No, he hasn't.
You don't?
He doesn't.
No.
It's not correct anyway. I thought you already had a paper. You don't? You'll get one, I'm sure. You keep trying. All right, somebody else. What's the answer to this? Okay, so what does a char star represent? It represents a sequence of characters. Can it represent embedded nulls? No. What does an STD string represent?
It can. But excuse me, it can. Of course it can.
Not by itself.
Without a length.
How we interpret the characters in this sequence of characters.
Okay, work with me, I'm on a budget. I will accept that answer. But you already have a paper. Now, there's one thing that a const char star can do that a string can't. What is the one thing that it can do? What unique value can a const char star represent that a string can't? No, give him a paper. So I've got one thing that can represent non-nullable strings that is itself nullable, non-null embedded strings that is itself nullable, and I've got something that can represent embedded nulls itself that isn't nullable. So finally, somebody tell me the mathematical type that represents the union of these two things that approximate it. We normally go the other way. So give it a shot. Somebody tell me.
Pointer to a string?
No, what's the mathematical type? Like what is the, what is the, you said pointer to a string. This is already including const char star, which is a pointer to a set of characters. There's some type.
Pointer to a string.
Okay, that's interesting. Pointer to a string, pointer to a string. Okay, what was your answer?
Okay, so it's strings with potentially embedded nulls, which as well as the null string.
How would you represent that in C++? He said a pointer to a string. You can say it.
Binary buffer.
Well, I know what the answer is, but I'm just saying that you haven't defined what you mean by mathematical type.
Okay, I see, this is what I mean. We have somebody who's more mathematical than I am. What I mean by mathematical type is a platonic ideal, and you could do it better than I can, where you're thinking about something that has nothing to do with programming, and you're saying, if I have an instance of this mathematical type, and I have another instance of this mathematical type, and I do an operation defined on this mathematical type, what would be the new value of the set that's part of the mathematical type? You want to improve? Go ahead.
Just come to my talk next, and then I'll...
I'm coming. I'm there.
Okay, I'll give it a shot. So I would say a pointer to a piece of memory and a size.
Okay, I think his is closer. I would have said a nullable string, but since he said a pointer to a STD string, I'm going to give you the best guess there. I think that's good. And I am coming to your talk, and I'm coming to your talk tomorrow, and we'll talk at the bar. By the way, he's the guy that I drove him home with. Jesus Christ. I don't want to get it wrong. What is your name again? I'm bad with names.
David.
I knew, that's what I said, but I didn't want to get it wrong. David is awesome. He's a tough sell, but we're getting there. So anyway, the point is, if I have Fred, and I'm representing Fred as a const char star, and I'm also representing it as an STD string, and assuming both of those come from the same mathematical model, are they the same value?
Yes.
Okay, good. Remember what I said. If they were designed in terms of the same mathematical type, then yes. If not, no. Okay, this is important. What about integers and integers mod 5? Are they derived from the same mathematical model? Who's sure? Who wants a paper? Do you have a paper yet? Are you sure?
Yes.
Okay, give him a paper.
He doesn't have a
All right. Anyway, the answer is, just like int and unsigned, they come from different mathematical models, which is why we don't use unsigned when we mean int. We use unsigned when we mean unsigned, which is rare. We usually mean int. Just because an unsigned has an extra bit for you if you don't need negative, that doesn't mean that the operations are the same. Don't even get me started. All right. So these are some important properties. I'm going to let you read them because I need a drink of water. But it's important that you understand that it comes from the instance state. It doesn't come from any other state. I'm sure you would agree with that, right, Sean? Okay. Have I gone too far afield yet? Am I okay? Still good? Okay. It may be recursive. We can build a point out of, we can build a point out of integers. We can build a box out of a point. And you notice the return, the attribute origin returns a point, so it's recursive. All right. What are the salient attributes of a vector? Here's a vector. Notice I left out the allocator so I didn't alienate too many people. What are the salient attributes of a vector? I have no idea. What?
I think it depends what you put into them. If it's integer, then of course the value is the series of values. If it's some pointer type, then it might be more.
I'm not. You need to keep talking, but that's not quite a paper. Somebody.
The ordered set of its values, of its contained values.
Okay, so what's the first attribute that matters? Size. All right, I'm going to give. He tried. Give him the size. Now, the second one. What is that?
Or a pointer to memory.
Somebody said capacity. Who said capacity? You said capacity, really? Okay. Okay, what? What did you think?
Well, the result of the square bracket operator is the other salient attribute.
Do you have a paper yet?
Yeah.
Okay. All right, so it's the respective elements, right? They have to compare equal. They have to represent the same value. Now, is capacity salient?
No.
Everybody knows that. How do you know that? Seriously, how do you know that?
We have to because it's C++.
Okay, fair enough. You have to know that. Okay, salient attributes, they're part of the logical design. They should be natural intuitive. They must be documented explicitly. That's my water break. Okay, why is value important?
It's the basis of equality.
It's the basis of equality.
Sounds great.
Yeah, all right. Give him a paper. Give him a. You got one? You've got one? All right. It's just you keep track. There's no double papers.
Saturation pretty soon anyway.
Well, you know I can cause inflation over here. All right, so it's important because we need to talk amongst different computers. In my day and age, we didn't have to do that as much. Just write something on a computer was all good. Now we have to communicate. This is actually really important. This is like one of those seminal slides that until I wrote it, I didn't realize how important it was. When I say slides, my slides are never one slide. So you've got an abstract data type, let's call it date. It's got some values associated with it, possibly infinite. You've got a C++ class. You've got some objects. What do the objects do? They represent values in the Platonic mathematical type. That's okay, right? I said it right? I'm going to begin your talk. I'll just throw out all these slides and just rewrite them based on what you say. So I got a database, and I want to put the values that the date object represents in the database. How do I do that? Well, I do it in some funny, database language. I don't even know what I'm doing, but they still refer to the same Platonic ideal, right? That's what I mean by value. And now, God forbid somebody wanted to write some Java code and suck those values into their Java objects. They're not sucking any values into their objects. They're simply referring to the same values that the C++ and the database were doing, right? Now, my goal here is to communicate the difference between an object and a value. A value is referred to by an object, but an object is not a value. And the terminology is key to understanding where we're going shortly. So this is not an academic exercise. This is how we communicate. So which types are naturally value types? All right, that's not all the types, but give him a paper because he's smoking. Do you have a paper yet?
I've already gone.
Oh, you guys who don't have a paper, all right, you guys who have a paper, stop answering questions so that when I say give him a paper, it does something. It's not reasonable. All right, now you remember this. This is deja vu from 2008. Sean was there. And this is all he remembered from my talk, is there was that damn flashlight. All right, so what's the state of the flashlight? Get ready with the paper. What's the state? Off. Who said off? You have a paper. Give him a paper. It's off. I'm not giving a paper for this one. What's its value? Don't even answer that question because we don't know. Is it 1? Is it false? Is it $5? Okay, any notion of value here, and this is where I disagree with some very smart people. Flashlights don't have a natural value. Am I crazy? Yes, but for other reasons.
That's irrelevant.
That's irrelevant. Thank you. Now, I want you to look at these things. And I got into a discussion about this one in particular. Some people believe a scoped guard has a value. That's about as far from what I can deal with as I can deal with. Because, look at a thread pool. Can we copy a thread pool? And if we copied a thread pool, what would it mean? By the way, this is a sarcastic question, but if anybody can give me a halfway intelligent answer, I really would love to give them lots of papers. Go ahead.
Clone a computer.
Clone. What does that mean?
That means, just make a complete copy of a computer in its current state with memory and everything, and you've got 2 thread pools with the same value.
One thing that's interesting, though, you have gone a little bit outside the language. Okay, I would give you a paper for that. I actually think that's very insightful. So I'm going to go to his talk. I recommend that all of you go to his talk because he's a smart guy. How about this one? Could we invent, did you say yes to this? Do you believe we could invent a definition, or you think it has a natural definition?
Yes.
Awesome. So here's some more things that I don't think have a natural notion of value. And this is where I differ from very smart people like David, whose name I will really try to remember from now on. I will be called Goliath, and you will be called David. That's how I'll remember it. All right, question. Suppose we have a thread-safe queue used for intertask communication. Is it a value type? This is the pivot point at where we can argue. This is right in the middle. That's why I picked it. And the point is that the purpose of this thing and the way it's written and its goals are all about communication and not anything having to do with value. Now, you could say that its value is the sequence of elements in the queue. But should we bother to make it support value syntax? That's debatable. My tentative answer is this is where we cross just over the line, and you might do it for testing purposes, but no one would use it to communicate a value outside of process. Now I want to ask Sean, I'm going to give you the last word on this. Does this represent a value or not? Whatever he says, it is.
So I claim it does represent a value.
Fair enough. This is, but you see what I'm saying? There are things that don't represent a value. There are things that do represent a value. And there's this muddy region where, depends. But the engineer writing the type has to make that call. So if you,
I would agree with you that in this case, choosing not to copy it is probably the correct choice. But for
Well-
one thing, it's not complete.
well, copying is not a problem, as you pointed out rightly.
Right.
It's asking the question, does this queue and that queue, do they represent the same value? And as you pointed out in your talk, asking that question can be hard, as we'll see. See, the more I think about it, we're very close in what we think. It's just the subtleties. Yeah.
Because I'm trying to grok all this.
Oh, it's so easy. Come on, it's just values.
Okay, but like, so a thread-safe queue, is the number of threads in there a value?
Oh, no, I'm sorry. Let me explain. A thread pool
Yeah.
is a mechanism that's used to deal with jobs and whatever. A thread-safe queue, and I apologize for this, and I'm not a very good threading person, but I'm just giving you an idea. Thread-safe queue is you've got one thread. Did you want me to?
No, what I meant is the number of items in the queue. That's a value.
Yes, but it's just another sequence like a vector. A thread-safe queue is a sequence of elements, has operations on it. The point is those operations are intended to allow two threads to communicate, and the way they're written is different from the way a non-thread-safe queue.
Okay.
Well, the point is, in that case, you can ask for something like, how many items are in the queue? But well, we know that this answer is pointless once you got it.
Yes, very good point. You have a paper already, right?
Yeah.
That's what I'm saying. The way you write it, you're asking for a snapshot answer, and talking about, like, are these equal? No one cares, because it's as soon as you get the data, it's stale. So this is, yeah.
So a value type is not a value type if the value doesn't persist?
That is not what I'm saying. Nico. Nico says if the value doesn't, what Nico said, if the value doesn't persist, then it's not a value type. I'm going to try to make this as clear as possible. I'll get to you in 1 second. You get to decide whether any type is or isn't a value type. You get to make that call. As an engineer, I would not make a thread-safe queue whose purpose is to communicate among tasks a value type. You would? Up to you. Yes?
Well, that kind of observation might be, I don't know, stupid, but you could use the value semantics and a copy and a comparison. If, for example, you want to check whether a progress was made on the queue. So one way would
Oh, so you want to take a snapshot of the queue.
and then compare it later to know whether any progress has been made.
So what I would suggest here, this is my thought, you would have a method on the queue that says, give me a snapshot. Not the entire queue, because that's not what you're interested in. You're interested in the relevant status or configuration or whatever, and you'd use a different non-thread safe type for that, perhaps, like a vector.
But wouldn't they, so you're interested in the value of the queue at that point, and then later on to see if the value has changed?
Again, if you have a reason for doing this and you want to implement those operations, as I said, it's your call. Okay, you?
I think an interesting value would be wait time.
It's something you can, by the way, value types represent a value. Mechanisms that aren't value types can have attributes that are value types, yes?
Well, you can claim that both the snapshot state or the waiting time, those are values you can extract from the thread.
Exactly.
But they are not the queue in itself.
The queue in itself may or may not have its own value, but you can certainly get values out of it. All right, let me go on.
What is the thing that gives meaning to the queue?
Well, what meaning is it's useful.
Yeah.
Like, it doesn't have to be a value to be useful.
I think a good criteria would be, are you ever going to compare it to another object of the same type?
That's exactly, yes.
If you would compare two of these thread queues, you probably would not compare.
That is exactly what I'm claiming. So we refer to, yes.
So is a function of value then?
I'm going to hold off on that because you know better than I do.
So
So I'm going to defer to you on that one. I think it is, but representing a function is harder, and as we'll see, they're hard things to represent. Go into your talk, we'll have that drink. Is your answer yes? Okay, I think we're on the same page, yes?
Let's take away the notion of thread safe.
Mm-hmm.
Okay. The queue itself. Vector, we said was a
Absolutely.
queue itself.
Absolutely.
So, why does thread safe?
What I'm saying is, as an engineering point of view, the reason for the existence of a thread-safe queue is to communicate across threads.
Right. So, what does thread safe change about the queue?
The way it's written, the purpose of the thing, in other words, it's not used to communicate values, it's used to transmit information.
Right. So I would say what you're saying is that you have an implied set of relationships on that queue, right? And you're
I just say purpose.
You still have a value there. You're taking away your ability to compare it for equality because you don't know how to deal with those relationships that are attached.
I would just say to you, I do know how to deal with them, and I may or may not choose to send people down that path. Yes.
I think what you define in value is a value that is part as a part of interface. Like what we have seen, it doesn't matter how you implement it.
That's true. Doesn't matter how you implement it. It's what you can observe in the interface. Yes.
A thread-safe queue, the thread-safe added to the queue makes the value of the original queue no longer a part of the interface.
Not so much. I really do mean this. I'm going to move on because, as I said, I want to get through this with time for questions, but I want to answer this. It is a matter of engineering whether or not you ascribe a value to that thing. It's not wrong. It's not right. It just is a choice. And as I said, I picked that thing so we could argue about it, but I don't want to argue anymore. We'll talk about it over drinks. All right. So look, here's my taxonomy, and you're right here at mechanism. By the way, we'll talk about this later, you can go look up these things, not all of them unfortunately yet, online, and Kevin can tell you how to do that. But this gives you a little bit of an idea. There we go. Thank you. You already have a paper. Okay, so I just want to point this out. We have an object, we have a stateless and a stateful object. Those are two places we go down when we go to design things. We could have any of these things as stateless objects, and this is an example of a utility, and it's an important class category. You will notice, by the way, I'm going to back up one, you will notice that I'm putting a static method in a struct rather than using a namespace. We could talk for hours about why I do that. It's better for me. It's more efficient. I will explain. And eventually it probably won't be. But this was deprecated and undeprecated. So it exists and it works and I love it. If you don't like it, it's okay. But I'm just pointing that out just to make everybody upset. All right, and then, just so you see as a utility. And then we have things that either are stateful and they're either mechanisms or values. They either are trying to represent a value or they're not. If yes, no. Let's say that again. Yes, no. That's a decision you have to make. So these are common class categories, and that is a pure abstract interface. Somebody asked a question in Sean's talk. What does it mean for two abstract types to compare equal? Does it have to do with multiple inheritance and Okay, what do you think? What does it mean?
They refer to the same value.
Well, that will work all what? Yes? Okay, so here's a thought, a provocative thought. You represent values with data members. And who said this? This guy Cargill, I read his book. There were three. There was Myers, Murray, and Cargill back in the 90s. And I read their books. And I learned something from each one of them. Myers, obviously, I learned a lot from him. Or at least I agreed with him by the time. I was already teaching a course at Columbia by the time I read his book. Murray taught me that he explained amortized constant time. Basically, I didn't realize it. I thought if you had geometric growth, you're going to wind up paying more than a linear amount of copies until I realized, wait, no, you're not. So Murray gave me that, and Cargill taught me this. So if you want variation in behavior, use inheritance. If you want variation in value, use data members. It's concrete. This is actually really important, and everybody that tries to put operator double equals on abstract types is like, why? You have no clue. All right, good. What syntax should value types have? Now, this is the least important part. It has nothing to do with this, so I am simply going to go through this, and I'm not even going to talk about it, because you all know this, right? It's just going on the slide. Regular type. Now, I don't even know for sure if I know what a regular type is, but I think the idea is, if it has all these good properties, syntactic and semantic, it's regular. Is that about right?
That's about right.
All right, good. I don't care. Okay, I don't care about this. None of these matter. I swear, none of these matter when we get down to the essence. That's what I'm trying to communicate here. Now, we can argue whether they matter. Of course they matter. I'm even advocating we do all this stuff. There's no reason not to. You should do it, unless there's a reason not to, which we'll get to. What am I talking about here? Who can tell me what I'm talking? It's worth a paper. What?
Conversion routines?
Conversion routines. Help me. Keep going. I need to know an answer.
Are they comparable types? Can they convert to a type that is comparable? That results in.
I think that's worth a paper. Give him a paper.
I got one. I'll give it to someone
Oh,
else.
damn. All right, hold on. All right, so anyway, I just want to point this out. Suppose we have a class T and a class D, and I want to compare the two, and I make this a member operator. This is a bad idea. If I make it a free operator, it works. Why? Because of conversion on the left-hand side of members doesn't work. That's why you were close. Good. Now you might say, well, I get a little fancier here. I've got these two methods, of course, but I'm going to put that one inside because I can. No, you can't. Because I can construct something that will break. And this is a bad idea. So just don't do it. Free operators are good, and it works. And I just want to just point, this is just because all of these things are free operators, and these aren't. Okay. That was all the syntax I want to talk about. Pretty much. Okay, so this is sort of a definition. How do we capture value in an object? How do we do that? That's not really what I mean. How do we capture the meaning, the semantics? How about a copy constructor? Does a copy constructor give us enough information to archaeologically extract the value? I see a no. Anybody think yes? Well, we may or may not copy the capacity, but that's not part of the value. So whether we copy it or not, who knows? If we copy it, does that mean it's part of the value? The idea is the copy constructor does not contain enough information to know what the value is. Okay, change it around. Suppose we make operator double equals a place that we can archaeologically extract the definition of value. The goal here is that if we're proper, two objects have the same value if and only if they compare equal. That's a regular class, right? You would never have operator double equals say, yes, they're equal, but if they're not, if it returns false, they still might be equal. And we'll get to that a little later. In other words, it decides the question. And so this is good. The implementation is a definition, and the contract is the specification. That's where you go look in all of our code. You want to know if the type is a value type and what value means, jump to the operator double equals and it will define value for you. If there's no double equals, it's still possible it's a value type. We'll get to that later. It's still possible. Unlikely, but possible. Would you agree it's possible?
I would agree it's possible. I'd also weaken your definition of operator equal.
Well, how would you weaken it?
What's that?
How would you weaken the definition of operator double equal?
Just because the expected complexity of operator equal is that it's proportional to the area of the object, I would allow a representational equality because it's very useful.
Okay, I'm going to defer that, but I think we'll be talking about that shortly. Yes?
A quick question. So the area of it, is it more that everything that you have to do to convert it to determine its value for comparison to another object that's also a value, all of the work that you have to do to compare its value, that's the order of operation? That's the amount of work you have to do?
Yeah. To determine that something's equal, you have to look at all the parts.
And
that's the expected. But sometimes looking at all the parts and figuring out what the corresponding parts are can be way more complex than just linearly going through the area of the object.
But I want to argue this. I understand what you're saying. What you're basically saying is, and we'll get to this, that sometimes the complexity of the operator double equals that you want is too large.
Yes.
So you're going to give somebody something else. You wanted a Rolls Royce, I'm going to give you a Toyota.
Exactly.
Okay, I'm going to talk to you about that later. Yes?
Guess I implement operator equal for vector that it only returns true if the capacity meshes.
Sure.
So would that mean that capacity becomes a value?
It's salient. It's absolutely salient. And that's your engineering choice. I don't like you anymore, but go ahead. What?
Then you also have to modify the copy constructor, otherwise you're...
Of course. And who wants to buy that vector from Nico? Anybody? I don't think you have any takers for that.
I'm tempted.
It compares really fast.
Yeah.
All right, if you guys want to buy it from Nico, look, it's for sale. All right. So I'm just putting this up. This is just for spite. I put this one up here. I wrote this in 2008, remember, because my allocator model was deferred. So I made this slide. What does it mean to assign a value? Is everybody good with this? Watch carefully. See those bits? This is kind of like your talk registers and stuff. Does this make sense to you? Now, does this make sense to you? I hope that makes a point. But let me just drive it home. Should move semantics move the V table? No? Why not? Why not? I'm going to put it in a paper. Anyway, this is just my spite. Turns out, all right, never mind. That is important, actually. So I said I wasn't going to talk about this anymore, but I kind of think I have to. Might not exist. Almost regular. This is where we disagree. You would put an operator double equals in that doesn't do the right thing. I would leave it out and make it a named function. It's got to be independent of that thing. Okay, here's an example of something that's not quite what we're talking about, but I still want to point it out here because it can have syntax that makes it look an awful lot like it's a value type, but it's not. So what does this mean? I've got a pointer to a record and an index, and here it is. Here's the pointer, and here's the index, and clearly they're attributes and they're salient. Two-element objects have the same value if they refer to the same record object in the current process, have the same element index. So look at this picture. These are element pointers. What's wrong with this? This is definitely worth a paper. Something is wrong with this. Go ahead.
Objects 3 and objects 4 are equal, but they don't compare equal because they're not in the same record.
I'm comparing the records. Remember, I want to know about values. I want to know about comparison of the element pointers. Is the value of the record that the element pointers point to? The record is an autonomous object. So the element pointer doesn't own it. It isn't like the data in a string. It's something else. So the question is it relevant what the value of the records are? Okay, point. Who said record was value semantic? It isn't. Or maybe it is. But because it's autonomous, if I depend on it and then somebody externally changes it, they wouldn't be equal anymore. It would violate a very common belief that if I have two values and they compared equal today, and I look at them a couple seconds later and I didn't change them through their interface, then they should please be the same, otherwise things are crazy. So that's not the point. The point is that three of these things refer to the same object and have the same index, so that's okay. And if that thing changes, they're still okay, because I can refer to it separately. It's an autonomous object. This is in-core value semantics. It's not full value semantics. It is not the focus of this talk. And I put this at the bottom. If I were subjunctive mood to ascribe a value to a scoped guard, it would be one of these things and not a platonic value. I don't know if that makes sense, but anyway. Question?
Yeah, this is just a thought going back, not about what you talked about, but previously with the move taking the V table. So if a value, say we have the set of unsigned integers, those are values, and then I have a set of signed integers, which actually represents a superset of the
They're different operations. They are not the same thing.
They're not the same, but in terms of value, if I can assign an unsigned value to, sorry.
You can in C++, but they're not the same type, so you need to go across types, and that's beyond the scope of what I want to talk about today. I have to move on. We can talk about it over alcohol. Okay, now here, this is definitely worth the paper. What do I mean by properly? Okay, this is actually really important. Remember I said it wasn't about behavior. This is actually the finale of the talk. Because one might allocate, the other one might not. They might still represent the same value. But if A and B initially have the same value, what should I roll up my sleeves? And same operation is applied to each object. Then, absent any crazy stuff, they will again have the same value. This is the fundamental, essential property of value, and it's not easy, and this is a long story, which we're going to talk about. I have only 35 minutes left, so I'm going to have to buzz along. I just want to point out that this is a sequence of operations. It's not a test driver, it's a specification. Now, suppose we have a homegrown ordered set. You know, the ordered set that we have, if you try to supply two different comparators, you'll get different types, and this question is moot. But suppose I have this crazy ordered set, and I can set the comparator operator to be either increasing or decreasing. Now the question is, here we go. What if I construct one set with the flag true and the other one set with the flag false? They're the same type, and they're both empty. Do they compare equal? Who said no? Give that man a... Absolutely not. Watch what happens. What happens is when they're initially... By the way, can you tell me why they're not equal?
Because later if you extract extract objects from those two ordered sets, they don't give the same sequence of operations.
Okay, suppose I add the integer 5. Do they compare equal?
If you only do this operation, yes. But
Wait. Do they compare equal? The answer is no. Why? Because when you add 6, they're in the reverse, they're not in the same order. Remember this thing? This has to be true for them to be equal. So if they're empty and equal, and then two adds later they're not equal, they never were equal.
yeah, that's what I said.
Well, you got the paper. You don't have to justify it. Go ahead.
What if the order is not part of the value?
Can you hold 3 slides? 3 slides. I think it's 3 slides.
Ordered set.
Hold on. We called it ordered set. Now, we called it that for a reason. Names are important. Okay? So, now we're going to talk about salient operations, because when I said operations, I kind of lied. I don't mean all operations. If you look at unordered containers, they are who knows what's going on there. They don't really encapsulate what's salient, because they were used to be called hash maps. Now they're called unordered maps, right? So, having said that, now you can talk.
Well, to me it sounds like we can say that order is not part of the value, and
You already have a paper, right, or no?
no.
Give him a paper. I would say, and I don't think anybody would disagree, although they did at the standards committee until I jumped up and down and other things. They said unordered containers, order is salient because it's faster if it's ordered, iteration order. And are you kidding me? What is an unordered container? What is an unordered multiset? You go out trick-or-treating. You get back a bag of candy. You talk to your sibling. What do you have? I have a bag of candy. Do they represent the same value? Everybody knows how you do that. You dump it out on the floor. You line up the candies. If there's a one-to-one correspondence between the candies, then they're the same value. Otherwise, they aren't. That's it. That's the answer. They didn't like that in the standards committee because it was too expensive. No, it's no different than anything else. Everything in unordered containers has a worst case complexity that's an order of magnitude. I say everything, not everything. Order of magnitude worse than expected value, and just get over it. Anyway, they got the right answer, so it's all good.
And it's not true that they didn't like it. We accepted that proposal.
They didn't like it, but when I say they didn't like it, not everybody liked it, and I had arguments with certain people who will remain nameless.
There are enough people who liked it, otherwise it wouldn't be in the set.
Fair enough. Hey, by the way, a lot of people don't like what I say right away. Physical design was very unpopular back in the 90s. I don't have to sell it that much anymore. You know, I'm kind of persistent like that. All right, so now we're talking about the same type. We're not talking about different types. So as soon as you go to different types, this no longer holds. This is, by the way, undefined behavior. All right, how do we design proper values? I am going to race along. This is an old slide. I do want to point out that some people get the idea that they can make some extra requirements in operator double equals, and I don't like it. What if we made the salient attribute the ratio? So we can get at the numerator, we can get at the denominator. Doesn't matter. As long as the ratio is the same, we're all good. Two rational objects have the same value if the ratio of the objects of the numerator and denominator for LHS is the same as that for RHS. So if I ask my daughter, who's, how old is she now? She's just 13. Even when she was 6, she knew those weren't the same. I could just ask her. This doesn't matter. This is just, don't worry about that. Are these the same? What about this? The problem is if you can really represent that, and you don't have infinite precision integers, then if you raise them to a power, you get undefined behavior on the right side because you overflowed them. That's a bad design. So I say this is a bad design unless you have infinite precision integers, which we'll get into something a little bit later. It's probably a bad idea. If you maintain the thing in a canonical form, it might be a little too expensive for you. So it's a design decision. But moving right along, everything that contributes to value that's accessible should also compare equal if the two objects as a whole compare equal. That's my advice. Yes.
So each of the individual attributes also should
Salient attributes.
Or is it the combination of the salient attributes?
No. Here, let's do this. If I have two objects, their value is semantic. The overall value of the objects compare equal. Each attribute that contributes to value that is extractable should also compare equal.
But what about the rational numbers where it's like, I care about the ratio?
I'm saying don't do that. I'm saying make sure that if they compare equal, then they have the same numerator and the same denominator. That is a suggestion. You can get away with not doing that if you have infinite precision integers because then one won't overflow. But you're going to make your life very hard, right? You like canonical representations, right?
Yes.
See? We're not that different. Don't you realize after talking to you, we agree on so many more things than you thought? Okay, I don't know what you thought, but I know I agree with him a lot more than I thought I did when I started talking to him. When should we admit value semantics? Now, you already gave this example. I'm just going to blow through this. This is like a plug for my book because we can have a bunch of different designs, but we're going to go for the simplest one, which is just two types here. And I'm going to use the way of access. You even mentioned you could have an index in your talk. Remember, this is the same talk. You take this from me? I don't know. Anyway, so it's not important what the details are here. I left out a const here. I'm sorry. The idea is we can access from the graph, we can access the nodes, and here we've got a node index on the node, so we can ask it what its index is, and we can find the adjacent nodes, and there happen to be 2 for this one, and they happen to be 0 and 4, and now we have here our graph, and we want to ask the question, what does it mean for two graphs to have the same value? Does anybody in this room not know how to make a graph class that has a regular interface? Oh, come on, it's worth a paper. Okay, he doesn't know. Give him a paper. You're going to teach him right now. There is no problem making a graph class because it's not that different than any other class. It's just what does it mean? What does it mean for two graphs to have the same value? Two graphs have the same value if, what are the salient attributes of a graph? Somebody who doesn't have a paper. Nobody with a paper is allowed to talk. What are the salient attributes for at least a couple of minutes?
Vertex and edges.
Vertex and edges. How about number of nodes? Give him a paper anyway, he's close. How many papers do we have left?
Quite a few.
All right. Number of nodes, right? If they don't have the same number of nodes, it's over. Okay? Something else. You don't have a paper, you need to talk.
How they're connected, topology of them,
How they're connected, what are those called?
edges.
All right, give that man a paper. Number of edges. Also, number of nodes adjacent to each edge, right? Well, that subsumes that. How about specific nodes adjacent to each node, which is what you said? That subsumes that. Are we done? Is there anything else that's important? Now think about this. Two graph objects have the same value if they have the same number of nodes and for each node index, the nodes adjacent to node I in LHS have the same indices as those of the nodes adjacent to node I in RHS. That's a specification. Is it right or wrong? It's right? Okay, well there you go. It's right. Okay, so here it is. Adjacent nodes is edge order salient. In other words, if I look at a graph and the edges are coming out of the node in a different order, is that important? If you wanted to. You already have a paper. If you wanted to, you could say that it's important, but if you're representing it as a matrix where the edge is either there or isn't, it's not. You have to decide. But you have to decide what it means. That's important. Okay, we could maintain them in sorted order, then you don't have to decide. Canonical order, okay. So what happens here? Are these two things equal? Well, if you maintain them with hash maps, it's going to look like that. If you maintain them with ordered sets and trees, it looks like that. Can't quite see this. It's possible to get the order down here, but it's stupid. Don't even talk to me. So don't even think about this. The observation is it's not all or nothing. You can have a value semantic type, and it is really true that until 2010, the standard didn't want to do this, in large part due to performance concerns. And what really convinced it, what really tipped it was Howard Hinnett, awesome guy, didn't quite believe me. He believed that there should be a notion of value, but he liked the one where order was salient, until I reminded him that they changed the name from hash map to unordered container, and he goes, duh, okay, you're right. So he actually changed his mind. All right, it's not regular. However, if I want to explain to somebody that this is a regular type, except it doesn't have an operator double equals, okay. So a horse is a zebra without stripes. Got it. Okay, good. Number of nodes. So nodes, yeah, this, but not this. What about the node indices? And Sean, of course, brought up in his talk that this might not be so easy. Two graphs have the same value if they have the same number of nodes, and there exists a renumbering of the nodes in RHS such that for each node index, the nodes adjacent to, we already saw that, so we added this renumbering thing. And so just quickly, everybody knows this, I assume, because we're all computer scientists, or should be. Should isomorphism be part of the salient attributes of a graph? And that's an engineering decision. But what are the consequences? How hard is it to determine graph isomorphism? I will allow you to answer the question if you want.
I believe it's O and P.
Okay. Well, it turns out it's known to be an NP and co-NP. Not known to be NP complete. Not known to be in P. It's actually between NP complete and polynomial. There are a whole bunch of things. Now, it could be in P. It could be NP complete. No one knows. But it's hard. Hard enough. Thank you for that. So we are not going to do this for exactly the reason that Sean said. But what I would like to do is say we're going to omit it because it isn't what we want, and we're going to provide another function that does what Sean wants, and that's fine. I don't want people to advertise operator double equals as an imposter for what you really want, if you really want that, if that is the notion of value. That's my belief, because I want it not to only be regular, but semantically consistent, yes.
And well, in this design, also the node number was important. So under the criterion that equality means that if you apply the same operation, it stays the same, it also makes sense to not include isomorphism in the equal operator.
Depends on.
This is an engineering decision.
A label, or is it just
If
part of
you've
the
got
representation?
anonymous nodes, then to stay consistency.
Okay, I give you that. So here's the idea.
Yeah.
Think about something that's completely abstract. It's a graph. It doesn't matter how it's represented at all.
Yeah.
If those two things, regardless of representation, to you are substitutable, in all cases that matter, they have the same value. Otherwise, they don't. All right, good. All right. Why would we ever do this when we can't do it efficiently, or when doing so is off message? Again, I argue that the thread safe queue is off message. All right. Summary so far. When selecting attributes, functions may be equivalent but not the same. Graphs may be isomorphic yet distinct. Triangles may be similar yet different. Don't try to make operator double equals do anything more than just tell you if they represent the same value. So this is an example, and I've just an idea. Again, I'm using my static methods of a class of a struct, and that's all okay because I like it. I've been doing it for a long time. I don't want to change. I'm old. This is the utility class category. We say what means facilitates understanding, so I want to get people to stop using the word equal or equivalent, or you know what I mean. I want you to say this. Aliases refer to the same object. Objects that have the same value, say they have the same value. We don't even say they have different values. We say they don't have the same value. That way they either have the same value or they don't, because there are four possibilities. They have the same value, they have different values, they don't have the same value, and they don't have different values. Let's not do that. Don't use the word different either. Use the same and not the same. Okay, refer to the same value, represent the same value, all good. Okay, if we want to use equality, we say they compare equal, which refers to the equality comparison operator, so we can have the discussion, hey, they compare equal, but they don't have the same value. What's up? Okay. Equivalent, put that somewhere else. Oh, we made it to 3. Now it gets hard. We're going to ask this question of 2 different things. I hope I get done by 10:30. I'm really going to try. But this is cool stuff. What is a regular expression? Definitely worth the paper. Now, I want you to know that there is a regular expression class floating around somewhere. It's standardized, right? Oh my God. All right. Regular expression describes a language that can be accepted by a finite state machine. Is that true? Does anybody disagree with that? Okay. So there's a regular expression. It's not really important to know all the details, but we all know what regular expressions are, right? The thing is, the object regular expression is horribly named, in my opinion. All right. Why create a separate class for it? Regular expression class imbued with the value of a regular expression can be used to determine whether or not arbitrary string tokens are members of the language that the regular expression value denotes. So the regular expression class isn't all about regular expressions. We have something called stood string that works just fine to express regular expressions. But it does something else. So let's take a look at this interface. We have this class method called isValid. We have these creators. Copy constructor here. This one right here, of course, we use to imbue the thing with a value. And we can destroy it. And then we have manipulators. We have assignment operator. And whatever the value is, we're going to assign that. That's fine. And we have this set value. And of course, the regular expression could be ill-formed. But we would never pass an ill-formed regular expression. Why would we do that? We would have checked it with the isValid. Or we would check it on the way in and check the status. This is a separate talk. But I'm not a big fan at low levels of throwing exceptions when people misuse contracts. They should read the manual and get it right. Or if it's raw data, they call this function and check the status. If you call this function and don't check the status, it's a double fault. If you call this function and get it wrong, in a safe build mode, we can help you. But it's another talk. Okay, just pointing that out. And then we have Well, I just told you why both. And then this is member. Now, we could call it accept. We could call it matching. But I called it is member. Why? Because the token coming in is or is not a member of the language. And the value of this object is a language. Right? We talked about this. You don't disagree. This is getting close to that function thing, right? This is like almost right on the cusp. Yeah. Okay. Which operations are salient? This is definitely worth the paper, even if you get it wrong. Somebody tell me who doesn't have a paper, which of these operations are salient? Or just name one that's salient for a paper. I'll give you a hint, there is only one.
Is valid?
Is valid? No. Who said is member? You already have a paper. I said if you add, what don't you understand? Okay, thanks. There's just one, it's this one. The point is, all of the other stuff is crap, basically, because this is the only mathematical operation that matters. You have a language, you have a token, you put the two together, you get a bool. He's nodding. See, I'm right. If he says I'm right, I'm definitely right. All right, good. Let's think about this. Do you understand what I mean? The mathematical model, there's an abstract language over here, there's an abstract token string over here. You put the two together and they become a bool, and it's either true or false. Okay. Should it represent a value? What should the value be? I say yes. There are people that would say no. But I feel very comfortable saying yes to this. How should it be defined? The string used to create it? The language it accepts. Sean, what's the answer, in your opinion? While I get water. You can tell everybody. Okay, Sean said so, so you must be right. Do you have a paper yet?
No, but you promised me one anyway.
All right, we'll hold on to it, but you can have one.
Oh, yeah.
If need be.
I'll sell it later.
Oh, burn. Note that there's no accessor to get the string that was used to imbue the value. Now, my opinion is the answer is 2, and it wasn't just as a coincidence, but I never, even if I put that stupid accessor in there, it would be just like getting the hash a bucket from an unordered map. It's like, who cares? It's not relevant. It's the language value that matters. If we did put the accessor, it wouldn't be salient. Just like capacity for a vector, order of iteration for an unordered map, perhaps we should have named it something different because that we used a string to give it its value. I was talking to somebody on the phone today who was reviewing my slides, and he doesn't like the idea of making everything a value. I mean, anything a value almost, unless it's got some attributes and it's like a struct. Maybe we should have called this language, or regular language. Maybe people would be happier then. Change hash map to unordered map, people's opinions change. That's a bug. Oh well, that's what happens when you do things at the last moment. That's the first bug that I've seen. I bet you, if anybody saw any bugs or whatever, you can always send me mail or something. jlakos@bloomberg.net. Should the class be regular? How expensive is operator double equals? All right, I'm going to ask you guys to do a favor. I've been standing up for an hour and 16, 17 minutes. I would like everybody in the room to stand up. Can you all stand up? It's time for a little stretch, right? It's the 7th inning stretch. You're not standing up? All right, I'm watching you all. Is everybody up? All right, here's the game. What I want you to do is, when I have gone beyond the complexity of that operator double equals, beyond, I want you to sit down. Let's practice. If you can write that in order 1, I want you to sit down now. If you can write it in order 1. Because it's order, we're up to order log n. If you can, that's okay. But as soon as I go too far, now this is the tricky part. The first person who sits down on the right answer gets a paper. But if you sit down on the wrong answer, you can't stand up again. Okay? So this is the goal. Did I go too far? Can we do it in log n? Yes or no? No? I didn't see anybody sit down. Can we do it in square root of n? All right, that's just... Can we do it in n? Looking. Really? The idea is if we could do it in n, you're supposed to sit down. No one's sitting down. All right, can we do it in n log n? No one's sitting down. No? Who sat down? I didn't see him. All right, you stay seated. Can we do it in n square root of n? Can we do it in n squared? Is it quadratic? He's down. Can we do it in polynomial time? Who's sitting down? Come on. He's sitting down. Sitting down? He was first, but that's not the right answer. Is it in NP? What? No one's sitting down. Get out. Is it NP complete? We need to adjust the thing. Can you adjust the thing so it's up a little higher? We're really going to need that for this. You can just, okay. Is it NP complete? All right. Now I'm going to go crazy. If you guys think it's NP complete, when I turn this, the first one who sits down gets a paper if it is.
Yeah,
Is it?
It was somebody.
Okay, that's fine. So, anybody think that it's NP complete? No one's sitting down? Okay, good. You think, okay, good. Is it, it's not, is it P space? Is it undecidable? That means if it's P space, sit down. P space complete. No one sat down on that?
I'm sitting there.
Did you sit down for are you really saying you think it's P space complete but not undecidable?
Undecidable.
No, which are you saying? Is it P space complete or is it undecidable?
I don't know.
But when you sat down, did you sit down when I put up the sign undecidable?
Undecidable. Yeah.
When you put up undecidable, you sat down.
Yes.
Okay, give him a paper, he's right. It's P space complete.
Well, he has one.
All right.
But now he can get a book and a drink.
All right,
That was a tough one.
that was a tough one. And I think he got it for the wrong reason too. All right,
We can talk about it later. I'd like to know.
you'd like to know why?
Yeah.
Oh, that's no problem, here's the answer. I will admit I took this off the internet because I didn't have the symbols on my laptop. I couldn't figure out how to do it. You can, if you Google for regular expression equality complexity, and you look like on the fourth thing down, there's a blog that has all of these symbols. It's completely wrong. It's completely wrong, except I needed the symbols. So it's basically the same thing, except the complexities were completely wrong. It was awesome. I just stole it and fixed it. Is that plagiarism? I don't know. They actually got the space and the time backwards. That was really screwed up. Oh well. All right, I put it up there just so you could see. So it's clearly not going to have an equality comparison operator, right? Should we avoid value types where equality comparison is expensive? Should we just avoid them? No. My difference with you is I will put out no operator double equals unless it reflects my semantics. That's where we disagree.
Yes, and that's a fine point splitting hairs, so I can go.
Except it's the purpose of my talk. Thank you so much. As we know, copy construction and assignment aren't a problem. Anybody want to talk about this? I have 7 minutes left for the last example. I'm probably going to not do it justice. Go ahead.
What were the salient attributes again of the regular expression?
The salient attributes of the regular expression are, do these two language values accept the same set of strings, period. That's the salient attribute. That's why attributes are not just members of a struct, right? There you go. Sorry I forgot your name, David, but next time I will remember it. David, it's all good. I don't mean that in any other way, but just to remember it and to tease you a little bit. All right, what's a priority queue? This is my last example. Aren't you glad you stood up and stretched? What is a priority queue? Does anybody know? Does anybody want to say what it is that doesn't have a paper? Okay.
It's a regular queue that has associated weight of the items.
So regular queue. So does it come out in the same order but has different weights? No.
Weights based on the weight.
So the order is based on the weight. What are the properties of a priority queue? What are the functions? We're going to give him a paper. What are the important operations on a priority queue? And maybe top? He definitely gets a paper. All right, so what is a priority queue? This is a priority queue. It's got top, push, and pop. I'm going to show you a lot of stuff quickly. These are the salient operations on a priority queue.
Why are all three salient attributes and not only two of them?
Wait, what? There are three. There's an accessor. There's a manipulator to pop it and a manipulator to push it. The top is part of the value. You need to be able to know what's on top of the queue. Come on. But pop doesn't return anything.
Oh, yeah, I forgot that. Yeah.
Following the same library now.
All right, I went with that. There's a reason for that. You could explain it to everybody. Anyway, even if there were redundant operations, that doesn't mean they're not salient. They're just different ways of looking at the value. They're called...
Also, salient operations can be redundant?
Yes.
Okay.
Wait. I didn't say they were primitive. I said they were salient.
Yeah, I never heard this word before, sorry.
Well, you better put it in your next book because it's going to become the talk of the town. Anyway, I just picked labeled point because it's a regular type. It's not complicated. We don't have to worry about it. And I created a comparison function that deals with just the Manhattan distance, which is the absolute value of the sum of the coordinates from the origin. I mean, it's no big deal. This is not important. I'm just putting it up there. This is important a little bit because if you don't know what a priority queue is, or if you don't know how to use PowerPoint for hours and hours and hours on end, wait till you see this. So each element is labeled with its calculated priority. This is no longer this is an abstraction of a priority queue. You see a priority queue here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, looks like. Is that right? Yep, set 10 things in this priority queue. Now, the colors represent different values. So, can anybody tell me top? What is top? 2. Okay. It's 2. We understand top. Just clear? It's a constant time operation. These guys have different priorities and different values. These guys have different priorities and different values. Same priority, different values. Same priority, same value. Same priority, different values. You get the picture? Just wait, just try doing these. Now I'm going to push 2. What's going to happen? I put 2 at the bottom, and then I have to swap with its parent, so I bubble it up until it doesn't need to go any further. I swear, try doing these slides. Darn. But they're useful. I'm not going to do anything here because they're the same priority. They don't flow through. Okay. Oh, now I'm going to pop it. How do you pop it? Well, that happens. Then you start doing these things. So you swap it. You swap it again because that has a more urgent priority. Do you swap that? No. We're done. Does everybody understand how a priority queue works?
That's my best algorithm class.
That's your what?
The best algorithm class I ever had.
Best.
Your talk.
Thank you. It doesn't come cheap, believe me. All right. Why create a separate class for it? Well, it's actually useful. I don't need to convince you of that. Should it represent a value? Is it a value or a mechanism?
Mechanism.
You think it's a mechanism? I think it has a value. Do you think it has a value? You think almost everything has a value. I think it has a value. I'm assuming, of course, that the elements themselves have values. How should value be defined? How should value be defined? Good luck on this one. This is worth all the papers in the world. What? Yes, what is that? How do you define value?
How about if you just top and pop and get the order out?
Okay, but you have a paper. So he made a very good suggestion. Let's just keep going. Does anybody else have an idea? This is the single best example of value I've been able to find. We're going to go over by about 3 minutes. You don't have to stay for the last 3 minutes. It is the climax of the talk, but we're going to go over by about 3 minutes. 4 max. All right. Two objects of class priority queue have the same value if there does not exist a distinguishing sequence among all of its salient operations, top, push, and pop. Bookmark that. Should such a class be regular? I'm not going to make you stand up again. That was cruel. So we always have to ask that question, how expensive is it? Sean and I are going to agree on this one, I'll tell you right now. We're going to agree. How would we determine, how would we write such a function, operator double equals? Right? We're all shaking our heads. What's necessary? Same number of elements, same number of respective element values. Sure. Sufficient? Same underlying heap order, right? Because if they're the same state effectively, they might not be state, it might be values, but if all of the elements are in the same order, there's no question they're going to pop in the same order and everything's good. Okay? But is it necessary? So if they have the same order, heap order, of course. But what about this? They don't have the same heap order. And it turns out that they pop in the same order, but using pushes we can distinguish them. Ooh, it's nasty. Can we always do that? Definitely worth the paper, because this is unpublished until now. You know the guy who announced he solved Fermat's last theorem, and that was the crescendo? That's what you're going to see for the first time here. If we're not sure, should we implement operator double equals? Now suppose on 99.99% of the time, if I say it's not equal, then it's not equal, but it's always equal. Let's say I can't quite decide, but really if I say it's equal, it's equal. But if it's not equal, might be equal. Do I implement operator double equals? No. No way. Perhaps make it a named function. Probably equal or probably not equal. No problem. Suppose this. Suppose it were true that for any pair of priority queues where the linear heap order is not the same, there exists a distinguishing sequence of salient operations that distinguishes them. Suppose that were true. Would you implement operator double equals? What's the complexity of operator double equals, if that's true? This is actually an easier question. It's a suppose question.
Trick question by now.
Sort her in. Because if for any two priority queues that have a different heap order, they're not the same, then all I have to do is compare the heap order. But is it true? It was just a conjecture until recently. I finally created a simple proof, and here's a sketch. This is not important. I'm just putting it up here to explain that there's a proof that says if you have a different heap order for any priority queues, and the way it works is you find, we're a little bit ahead here, you find the first place. If you have, let's say you have two priorities, you find the highest index point where the priorities differ. Very evil. You find that highest index point, and then what you do is you start pushing lower priority values, they're like water, into the queue until you get to the right edge of the tree that emanates from that point, and you drop a high priority value and it goes up to that point. Here it's blocked because there's a high priority thing that stops it, but here there isn't. This is the lower priority one, and as a result it gets ahead. Then you add some more stuff, get to the left edge, and you drop a different color, and lo and behold, the orders are reversed. Then you fill the whole thing up with water, low priority things, then you start popping, and when you get to the top, they're in the opposite order. Sir?
Wouldn't you need to know the maximum value contained within the queue to do that?
I'm saying it doesn't, of course you could, that's not the point. The point is, does it exist? And you can know what you put in the queue. That's no problem.
Sure, but for you to get them, put that large value in to get the right behaviour out of the...
No, this is a proof. This is a proof that it could happen.
Oh.
It's not how to do it. Of course we could do it. We just iterate over the queue and find out what the elements are. That's not the point. The idea here is that it exists. Anyway, right now we'll pop two different values and before we did that, by the way, they already had different tops. So at this point they're not equal. So they never were. And now they don't even contain the same elements. So my point here is they really are not equal. So they never were. And the question is, should such a class be regular? Yes, it should. And it's O of n. And that's why. All right, discussion. I'm going to get to the conclusion. I think I went over 4 minutes. I'm going to be 5 minutes over. So what are the takeaways? Some types naturally represent a value. I think we can all agree with that. Ideally, each type will have regular syntax. We all agree with that. Operation of the value type should flow from proper value semantics. Value derives only from the autonomous object state, meaning it doesn't come from anywhere else but the state. Not all of the state has to contribute to value. It must obey the essential property of value, and it must behave as if it has a canonical internal representation, what you said. And I think I added that before your talk. Okay. This is what you need to remember. This is the big one. Two objects of a given value semantic type have the same value if and only if there does not exist a distinguishing sequence among all of its salient operations. Period, the end. It's in its DNA. It's not about whether it has an operator double equals. It's not about whether it has a copy constructor or a swap or an assignment or none of that. This has to be true. Then add some more operations for syntax purposes if you want. I don't really mean that. I really do want them to be regular. The key takeaway is what makes a value type proper has essentially nothing to do with syntax, everything to do with semantics. A class that respects the essential property of value is value semantic. Otherwise, it's not. And this is information for you to go look more at the crazy code base that we have. And I'm done. Sorry I went over.